Okay, this video is all about factorising. I'm going to do all of these without a calculator. There will be a second video showing you how you can use your graphics calculator to solve. But remember, you're going to have a test where no calculators are permitted. So we want to see if we can do this no calc. All right, we've got our basic steps for factorising, right? Make sure everything is equal to 0. We need to make sure we pull out a common factor, difference of two squares, etc. And then the last few we're going to look at sum and product. And not a huge fan, but we're going to look at splitting the terms for particularly difficult ones. Anyway, so we're going to look at these 9 questions. Let's start with the first 3. So remember, the first thing we want to do is make sure, I'll put the list back up again, is that we have everything on one side, and that's done already for this one. So now we check, are there any common factors? Clearly there are, because we can see the x. We check the numbers. What's the biggest number that goes into 21 and 6? Well, that's got to be 3. So that's what we pull out. 3 7s give me 21, and x times x gives me x squared. 3 times 2 gives me 6, and the x is already there. So that was pretty painless. And then we keep on going, and what we want to do is solve for each of these terms, right? Because that's 3x times 0. What makes that term 0? Well, we're solving 3x equals 0. So therefore, x would have to be 0 is, x being 0 is one solution. Now we've got a second solution from here, right? Remember, 0 times anything gives you 0. So we've got a second solution, and we're solving 7x take 2 equals 0. Simple algebra, whack the 2 on the other side and get rid of the divide by 7. Get rid of the times by 7, so we divide by 7. And those are our 2 solutions. So it's those 2 values for x when we replace them back in here. So if we say 21 times 0 squared takes 6 times 0, clearly we get 0. 21 times 2 sevenths squared takes 6 times 2 sevenths. That will equal 0. Those are the 2 solutions for this equation. Okay? So that's what we're up to. All right, with this one, same thing. Is it equal to 0? No, it's not. So one little step that we have to do, get that all on one side. We go through, is there a common factor? We've got x, but the 28 doesn't have an x, so no common factor. It does not look like difference of two squares, nor does it look like this for a perfect square, so forget it. What we're going to do is we're going to say, can it possibly be placed into factored form? So what we're looking for are 2 numbers that times together give you negative 28, but add up. So we're going to say times together give you negative 28, but add up to be 3. Now, hopefully with your wonderful times tables, you already know what these numbers are. But if you don't, let's be systematic. So does 1 go into 28? Yes, 28 times. Does 2 go in? 14 times. 3 doesn't. 4 7s give me 28. Does 5? No. Does 6? No. 7, it's on the other side. So now we know, we're confident, we've got all the possible factors of 28. So which are the only pair that we could possibly get 3 from? Well, it's got to be the 4 and the 7. And we want, when we add them together, we want negative 3. So that means it has to be minus 7 plus 4. Right? Hopefully this is all coming back to you. And of course, we're not done, because what we are solving for is x plus 4 equals 0. So therefore, let's get rid of the plus 4. So therefore, x is minus 4. And then we've got this one here, which is x take 7 is solving for 0. Therefore, x equals 7. Now, the question I'm sure that is burning in your minds is, do I have to write this line? Absolutely not. I hope that the more you do, you don't have to write that line at all. You will skip straight to the very last step. Okay, let's have a look at part 3. Houston, we have a problem. For starters, there's no x squared. We've also got this divide by x going on here. So what we're going to do is we are going to get rid of that divide by x. We are going to times every term by x. So x times x, x squared, minus 18 over x. You've got a divide by and a times by x, so that they cancel each other out. And then minus 7x. So we've got our x squared. What do we have to do now? Get everything on one side. So this is now x squared. It becomes plus 7x. Okay. Once again, we go through. Is there a common factor? No. Does it look like difference of two squares or a perfect square? No. So we're going to try and hope for the best to see, can it actually be factorized? So are there two numbers that times together give you 18 but add up to be 7? So once again, list your factors of 18. Okay, so I'll list them down here now because I'm running out of room. So we've got 1 and 18. 2 goes into 18 9 times. 3 goes in 6 times. Does 4? No. Does 5? No. 6 is on the other side. We've got all of our factors, and now we can see pretty clearly it's got to be 2 and 9. Now, when you times them together, that means we want a negative answer. So one's got to be positive and one's got to be negative. But when I add them together, I want plus 9. So clearly that's positive 9 and negative 2. Okay, remember we're making each bracket equal to 0. So we're making x take 2 equal to 0. And hopefully by now you're saying, why are you writing that? Can't you just go x equals 2? Yes, you can. And hopefully you can also say x equals minus 9. Okay, let's get ready for the next lot. And just like magic, they appear. So again, we're checking, right? Go back, always go back and check your routine. This is all about routine. So, oops, right? Make everything equal to 0. Pull out any common factors. Check if it's difference of two squares, so on and so forth. So here we go. Everything is equal to 0. That's good. Is there a common factor? Yes, 3. So we pull out the 3, and that becomes x squared 3 times 25 is 75. And now I'm looking at what's in the bracket, and to me, and I hope to you as well, but it looks like this, difference of two squares. Okay, so we're going to factorize that nicely to be x minus 5, x plus 5, right? 5 5s give me 25. I have a difference of 0. There we go. Notice you must keep the 3 out the front. You cannot ignore that common factor because each line has to equal each other. Okay? If you didn't have the 3, then what you would be writing is x squared take 25, and that is not the same as that. So do make sure it's all equal. Okay? We now want to make each one of these factors equal to 0, and that means x could be 5 because 5 take 5 is 0, or it could also be minus 5 from the second bracket. Okay, onward and upward. Feel free to pause the video and do them yourself and then check the answers if you like. Okay, once again, we're in our routine. Get everything on one side. Is there a common factor? Yes, there is, because everything is even. So we're going to pull out 2 as our common factor. And we notice they're all even. So 2 divide through by 2. There we go. Keep going. Is there a possibility that we could factorize? In other words, is there a possibility that there are two numbers that times together that give you 10 but add up, right? Times to give you 10, add up to be 3. So what are the factors of 10? 1 and 10, 2 and 5, that's it. So it's this, it's 2 and 5 is the pair. But again, when you times them together, you want minus 10. So one's got to be positive and one's got to be negative. Which one is negative? Well, minus 2 plus 5 gives me positive 3, which is what I wanted. So minus 2 plus 5. Finish off. So therefore, x could be 2 because 2 take 2 gives me 0, or x could be minus 5. Huzzah! Keep going while we're on a roll. Okay, we should be able to do these pretty quickly now. We want to get everything on one side. We're really hoping to get rid of the take 2. We add 2. We're really hoping that there's a common factor of 3, but alas, no go. So how can I factorize? We're going to see if we can do this. 3x times x is the only way that we can get 3x squared. This is really nice because the only factors of 2 are 1 and 2, right? So you've got two choices. Do we put the 1 here and the 2 here? If you did that, you get a 3x and a 2x. Now 3 and 2, right? 3x and 2x can give you 5 or 1x, and that's no good. So we're not going to even bother. Hopefully you're seeing 3 2's are 6, that's really close, and then you've got another, right? So 3x times 2 gives you 6x, and then 1 times x gives you another x, right? So that is our good to go, and they're both going to be negative because we know a negative times a negative gives me the positive 2 that I want, and 3x times minus 2 is minus 6x, take another x is minus 7x, so that works. And always check quick expansion that what you have put in the brackets, if you expand, it does give you the line above. If it doesn't, try something else. All right, so we're going to find our solutions here. So remember, this is now we're solving 3x take 1 equals 0. So the 1 has to go on the other side and get rid of a get rid of a times 3 by dividing by 3. So we've got x equals a third, and the other one has to be 2. All right, 3 more to go. Okay, for the last 3, we're going to look at factorising using sum and product, but also the method of splitting the terms. All right, so first one, everything is all on one side, so tick doesn't look like difference of 2 squares or a perfect square. Now, I would take maybe 10 seconds just to have a look and go, can I factorise this, right, without having to do too much effort? So the only way we can get 5x squared is to have 5x times x. What are my factors of 12? So I've got 1 and 12, 2 and 6, and 3 and 4. And what we're looking for is, can I times these together in order to get 23? Now, you know, what do we think about 1 and 12? 5 12s are 60, or if I put the 12 here and the 1, 12 plus 5, it's just not going to work. So that's out of the game, right? The other thing that I can think of to help myself speed along, both of these, 2 and 6, they're both even. Now, no matter what I times, if I times an even by an even number or an even by an odd, I'll always get an even number. So how can I have 2 even numbers and get an odd number? So that's out. So I'm left with 3 and 4. And lo and behold, 5 4s, right? 5 times 4, so if I put the 4 here, is 20 plus another 3x, bang. So if your expanding skills are up to scratch, right, factorising shouldn't be too much of a bother. Now what we're solving here is 5x plus 3 equals 0. So the 3 is going to go on the other side, becomes minus, and get rid of the times by 5. You're going to divide by 5. So you get minus 3/5, and then x plus 4 equals 0. Yes, I might as well write that down. Why not? And therefore, x equals minus 4. All right, so if you don't like that, then the second option is what we call splitting. Oops, my pen is now giving trouble, is called splitting the terms. So what we're going to do now is we're going to say 5 times 12, right? So 5 times 12 is 60. So this is a backup. If you can't really do it bang straight away, then you can try this. All right, what we're going to do is we're going to look for 2 numbers that times together. So we want to say times together gives you 60, but when I add them, right, I want 23. So we go through the same thing, right? 1 goes into 60 times. 2 goes in 30. Does 3 go in? Yes, that goes in 20 times. Does 4 go in? 18. Does 5? 12 times. So, you know, you're doing this without a calculator, which means you got to have your times tables with you. Oops, wasn't 4 and 18. What was I thinking about? Does 4 go in? So 4 goes in 15 times. Look at that, giving a lecture about. Anyway, does 5 go in? 12 times. 6 goes in 10 times. We could have stopped because it was here that we saw the 3 and the 3 plus 20 gives me 23. All right, so here we go. We write this down now. Have I left myself enough room? Let's hope. So I've got 5x squared. Now it doesn't matter if you say 3x plus 20x or 20x plus 3x. Both methods will work, right? I'll go the smaller first. Plus 20x plus 12. Right? So this whole statement here, if we add it up, it will be the same as our original question. So always just double check. All right, what we now do is we look at each of these. Pen's gone again. All right, we look at each of these and we say, is there a common factor? So we've got 5x squared and 3x. So we're going to pull out x is your common factor there. So I end up with 5x plus 3. And what a surprise that when I look at this second term, what's the common factor between 20 and 12? 4, right? Highest common factor. And 4 times, oh my gosh, 5x, look at that, 5x, and 4 times what gives me 12? So 3. So now I've got this common factor of 5x plus 3, and I'm going to pull that out. When I pull it out from the first section, I'm left with an x, and when I pull it out from the second, I'm left with the plus 4. And that, my friends, is the same as what we got upstairs. So if you can look and factorize quickly, right, this is going to be the quicker option if you know your times tables and you're expanding well. If not, then we go for splitting the terms. Okay, we've got another one of these. We're going to get rid of the divide by x by timesing by x. So we've got 6x squared equals 7x plus 3. We get everything on one side. Take 3 equals 0. Okay, not a fan of the 6x squared because I can get that in two ways. I can get that 6x times x or 2x times 3x. I am happy that we've got a prime number here because the only factors of 3 are 1 and 3. So I pop this down. Right, so I could have 6x times 2x, or I could have 2x times 3x. Clearly, with the 1 and the 3, right? If I put a 3 here, 6 3s are 18. I'm trying to get minus 7. If I put the 3 here, 3 2s are 6. And then I get another, if I have 1 times 6, so that gives me 12 or nothing. So that's no good. We do this pretty quickly. What am I after again? I'm after 7. All right. If I put the 3 here, 2 3s are 6. And 1, so that gives me a 6x and a 3x. No way that I can get 7x from that. So switch it. Now the more you do, the more you'll be able to see this pretty quickly. So 3 and 1. And lo and behold, 3 times 3x is 9x, and 2x times 1 is 2x. Now if I say minus 9, x plus 2, I get the minus 7 that I wanted. So that has to be the minus, that has to be the plus. And we solve, so x is positive 3 on 2, and x is negative 1/3. Shall we do this by splitting the terms? Let's. So we're going to look at, we'll write it again so you can see. So 6x squared minus 7x take 3 So we go 6 times 3. We're looking for two numbers that times together gives me 18. All right, we did 6 times minus 3, so we're looking for minus 18. We've got 1 and 18, we've got 2 and 9, we've got 3 and 6, 3, 4, 5, 6, we've got them all. All right, so which pair gives me the 7? It's that one. So we'd go 6x squared, and it's going to be 9 minus 9x plus 2x. All right, just check, does that give you minus 7? Yes, it does. Take 3 equals 0. And double check, does this line equal this line? Yes, it does. We're good to go. And now we pair off. Pair off, pair off. So what's your highest common factor between 6x squared and 9x? That's going to be, oops, why does that come up? That's going to be 3x. 3 times what gives me 6? That's 2. 3 3s are 9. And look at that, we've got 2x. Take 3. So now when I pull out this common factor of 2x take 3, right, what remains is the 3x and a 1, right? There's technically a 1 there, so we say plus 1. And that's what we got. If you have a look upstairs, that's what we got up there. So as I said, splitting the terms, I tried to use that as a backup if I can't get this first method pretty quickly. All right, last one. Let's get rid of the divide by x. We're going to times through by x, so we get 6 plus 12x squared equals 17x. 12x squared minus 17x plus 6. All right, so this is one where, you really do groan, because to do the first method, right, you are going to go through a little bit of trial and error, because with 12x, we can have 12x times x to get you 12x squared. We can have 2x times 6x, and we can also have 3x times 4x. All right, all of these will give me my 12x squared. Now, like we said last time, I'm going to get rid of this one because they're both even, and I want an odd one in the middle. So that's out. Now, the factors of 6, I'll have to do it up here because I'm running out of room, are 2 and 6, 1 and 6, and 2 and 3. Okay, I think to get your 17 in the middle, whether I put the 1 here or the 6 here, there's no way that I'm going to get 17. So that's gone. So pretty quickly you can rule out what are the ones that are just impossible. Okay, so what am I looking for? Okay, if I put the 3 here again, I'm playing around, but 3 3s are 9. And if I put the 2 here, 2 4s, right? 2 4s are 8. So 9 and 8 give me 17. Double check, are they both negative? Yes. So done equals 0. I can't fit it in. So x is 2/3 or 3/4. Okay, if we want to do splitting the terms, we are doing, okay, 12 times 6. So 12 times 6, actually I'll write the question again just so we can see it clearly. So it's 12x squared, take 17x plus 6 equals 0. So we're going to go 12 times 6 is 72. So we're looking for the factors of 72. That will give me 17. All right, 1 and 72. 2, 36. How many times does 3 go into 72? 28. Again, we're doing this without a calculator, so 3 goes into 7 twice with 1 left over, 28. 4 goes in 18 times, right? Again, 4 goes into 7 once with 3 left over. 8 4s are 32, so you still need to know your times tables. 6 goes in 12 times, 8 goes in 9 times. Right, and 8 plus 9 gives you 17. Oops, so that's our winner winner chicken dinner. So it's going to be 12x squared minus 8x minus 9x plus 6 equals 0. look for your common factors. Okay, so we pair off and we go common factors. So what's your highest common factor of 12 and 8? Got 4x, that's going to be 3. So 4 3s are 12, x times x is x squared. Take 2. What's your highest common factor of 9 and 6? It's 3. Now be careful because, oops, she says be careful as she makes a mistake. Right, 3 times 3 gives you 9x. Now, minus 3 times minus 2 gives you positive 6. I mean, the upshot is that these should be the same. So now we pull out our common factor of 3x, take 2, and we're left with 4x, take 3. And that's the same that we got up there. So hopefully that helps. See if you can do those questions from exercise 2A1.